you to my lecture today. I actually want to walk you through what I call contrasting analysis of variance. But before we get started today, I quickly want to have a recap on what we've done before. Okay, so that for us to be able to have a way to connect to today's topic. We started with the analysis of variance. And of course, analysis of variance enable us to compare between groups. Of course, when we're comparing between groups, we actually have a way to do that by trying to compare variability between and the variability within. And at the end of the day, I show you how you can actually take a decision regarding the non-hypothesis. Of course, the fact remains that if we're looking at the one-way analysis of variance, we have a categorical, we want to look at the effect of categorical predictor on the response. Of course, what we are actually comparing is the levels of categorical predictor. The numbers of groups that we're actually going to compare depends on the levels of categorical predictor. I walk you through how we can actually implement that, the one-way analysis of variance, in R. I also walk you through how you can test whether assumptions underlying the use of analysis of variance is met. Because a model is as good as assumptions put into a model. Now, from there, we move to what we call two-way analysis of variance situation, whereby the sources of variation is more than one. Because in one-way analysis of variance, the sources of variation is one, which is the one in the categorical factor. But situation where you have more than one categorical factor, then the variation is now more than one, and that is why we call that two-way analysis of variance. I remember I also walk you through situation whereby there is a certain available information in terms of a concomitant variable that may have effect on the response as well. And I remember we call that analysis of covariance. Analysis of covariance in the sense that in an attempt to look at the, trying to see whether there's a significant difference in the groups, if there exists a covariate that may also have influence on the response, then we're also going to incorporate that into our analysis. And we call that analysis of covariance. And I remember generally when we are whether you are conducting the analysis of variance or analysis of covariance, of course, the whole thing starts with the specification of two hypotheses, the non-hypothesis and the alternative. The non-hypothesis is actually going to say, okay, there is no significant difference between the groups. Of course, the alternative is going to say there is. When the non-hypothesis is rejected in analysis of variance, we normally conduct further analysis. I'm going to say that again. When the null hypothesis is rejected, whether in analysis of variance or in analysis of covariance, or in factorial analysis, or in randomized complete block design, or in whatever form of analysis of variance that we conduct, the moment the null hypothesis is rejected, we need to conduct a further analysis that I call Peerwise Comparison. You know, the analysis of variance or the analysis of covariance will only tell us whether there's a significant difference among the groups, but it's not going to tell us where the difference lies. Where the difference lies, if you want to investigate where the difference lies, then we need to compare groups head to head. That is what we call pairwise comparison. But let me tell you this. In a situation where I'm not interested in pairwise comparison, situation where we have rejected the null hypothesis, but I'm only interested in comparing specific group of treatment based on the prior information that I have. I'm going to say that again. Situation where the null hypothesis has been rejected, but I'm not interested in pairwise comparison, but I'm only interested in comparing specific treatment groups based on the prior information. Then I'm not going to use pairwise comparison, but I'm going to use today's topic, contrast. I wanted to see the building up to today's topic. Contrast in analysis of variance is actually telling us it's a further analysis that we normally conduct when the null hypothesis is rejected. But you know what? Maybe our interest is not on the pairwise comparison. We actually want to compare certain group of treatment means based on the information we have. And that is what leads us to today's topic, contrast in analysis of variance. Of course, the outline today, I'm actually going to walk you through contrast in one-way analysis of variance and contrast in two-way analysis of variance and how we implement contrast in R. That will be the focus of today. Now, I'm going to go into that now. What do we mean by contrast in general? The contrast in general will enable us to decompose, the sum of square treatments. What do I mean by sum of square treatments? It's like the total variations, explained by the treatment in the model. You want to decompose that into different, components. So that when you decompose that into different components, where they will be able to attribute a certain explained variation to a certain component. Now, the contrast is in terms of C1, symbolically, in terms of notations. We're going to call that C1, C2, up to CK. And in such a way that when I sum them together, because they are weights, the cumulative effect of them is 0. When I sum contrast together, it must give me 0. Okay, it must actually give 0. Okay, now, and this is the way the hypothesis is going to be, because we're going to have a contrast, going to be a linear combination. We're going to have a linear combination of the constant weight and the means of different groups. Before I go into the example here, I'm actually going to use an example that I know most of you are familiar with. Now, take a look at this. if I want to compare infection rates of COVID, okay, and I want to compare this infection rate across race, okay, I want to compare that across race. I want to see whether the infection rate across race is the same. Okay, of course, you know, I'm actually going to use analysis of variance, right, to do that. The race I'm talking about, maybe I'm talking about white, African Americans, Latinos. The levels of growth I'm going to compare, it depends on the levels of race that we have. Of course, the non-hypothesis is going to be there is no significant difference in infection rate experienced in different groups. But let me tell you this. What if I'm interested? Maybe I've conducted the analysis of variance test and I've rejected the non-hypothesis, maybe because the p-value of the test is less than a given level of significance, and I'm not interested in conducting a Peerwise comparison test that we did before using Turkey HSD. But I'm only interested in comparing infection rates of a particular race, white, let me just say white, with others. I'm going to say that again. When I say white with others, of course, with others that I'm talking about, we have African Americans, the Latino, and so on like that. It means I'm comparing one level of a group with 3 levels of a group. We can never achieve that with Peerwise comparison. The Peerwise comparison will only compare maybe white with black. That is one of the examples of a contrast. I'm going to give you another example of a contrast. You know, I'm still on the issue of the COVID. You know, if I want to, you know, most of the countries in the world are trying to see how they can actually, you know, reduce infection rates. And maybe we have 3 groups of treatment that we're going to compare. If we do nothing, that is without mitigation, you know, doing nothing means no vaccination, nowhere, nobody is putting on face masks. We're just actually behaving, as if nothing happened. That is without mitigation. That is control. And there's another level that I call putting on a face mask. Another level is social distancing. And another level is vaccination. I'm going to say that again. We got 4 levels here. No mitigation, that's number 1, which is control. The wear of face masks, that is number 2. Okay, social distancing, that is number 3. Then number 4 is vaccination. Maybe now, and I want to compare infection rates, because the only way to see if a particular intervention is working is to compare that intervention with nothing. I'm going to say that again. The only way to investigate whether an intervention is working is to compare the intervention with nothing. The first level, no mitigation. The second treatment, the wearing face mask. The third one, social distancing. And the fourth one, vaccination. What do we want to compare? We are comparing the infection rates when we have these interventions. maybe we have rejected the null hypothesis after conducting the analysis of variance. And we now want to, we have a prior knowledge of whether when we do nothing, when we do something, the infection rate is likely going to go down. That's a prior information that we got. And you know what we now want to do? We now want to compare two groups, but only that in one group, I'm going to have more than one level. Doing nothing against not doing nothing, not doing anything. Doing nothing is you don't wear face masks, you don't do vaccination, you don't do social distancing. That is doing nothing. Now, doing something is in 3 levels. But we want to compare doing something with doing nothing, then we're going to use contrast. We cannot use Peerwise comparison in that situation because the Peerwise comparison only applies to when you are comparing one level with one level, not 2 levels with 1 level or 3 levels with 2 levels. Does that make sense to everyone? That is how contrasts work. But in my provision today, in the example that I provided in the notes, it is similar to what I just explained. We have, looking at the equivalent, we have treatment and the control, and the treatment is divided into 2. With the control, we got 3 levels. And we actually, there's something that we call propranolol, and it's a drug that we use for hypertension. And you know what? We have 2 drugs that are equivalent, and we want to compare them with control. Okay, because of that, I'm actually going to have this design layout. And we're going to have control, which is placebo. Of course, the placebo, when you are giving placebo, then the placebo don't have any effect. It's like nothing. Then you have drug A and drug B. Of course, if we want to compare, of course, we got 3 levels here. You're going to use analysis of variance. But you know what? If we have rejected the null hypothesis in the analysis of variance, there's a lot of contrast that we can test, which I'm going to show you based on these 3 levels. Take a look at this. Contrast number 1. When you are constructing contrast, you're actually going to decide on the weight, on the contrast weight in such a way that the addition of the contrast weight must be equal to 0. Now, when you look at the contrast 1, I wanted to see something here in contrast 1. I put -1 on control, and I put half and half on the drug A and drug B. What does that mean? It means I'm comparing the effect of drugs with nothing, which means I'm and how many levels of drug we have? We got 2 levels. I want to compare 2 levels of drug with nothing. That's a contrast. That is what contrast 1 is talking about. Half plus half is 1. 1 minus 1 is 0. That's it. That is what the contrast 1 is talking about. Well, let me also tell you this. Peerwise comparison is a special form of a contrast, which means even within the contrast, we can also compare, we can do head-to-head too. If you look at contrast 2, in a situation where a level is 0, look at that, control is 0, right? If you look at contrast 2, then basically I only want to compare if there's a significant difference between drug A and drug B, and that is why I put +1 on this and I put -1 on this. It means I'm only focusing on the 2. So this is how here we are constructing 2 contrasts. And of course, the interpretation of that is actually what you are seeing here. Now you now see how contrasts work. with the contrast, you can actually compare a level of one with a level, this level with one level, or one level with two levels, or one level with three levels, or three levels, depending on the situation, depending on the prior information we got. I want to tell you this. I say prior information. What do I mean by prior information? P-R-I-O-R. What do I mean by that? That is the probability of the state of nature before we collect data set at all. A philosopher said, and I quote, "Our mind can never be empty. We always have something in mind. We always have something in mind. Maybe based on experience or on the news we got and so on like that. And that's what we have in mind is what we actually want to test. For us to be able to actually hold on to what we have in mind, then we need to go into statistical testing. Okay. Now, if you are constructing contrast, in the example that I just showed you, we constructed two contrasts. How do I know the optimal number of contrasts I'm actually going to construct given a problem? Okay, when you go back, we have three levels of the treatment we're comparing. The maximum number of the optimal number of contrasts we can construct is going to be 2. Why 2? That would be the numbers of group minus 1. It means I'm going to construct 2 contrasts for 3 groups. Now, and when I'm constructing my contrast, they have to be orthogonal. What do I mean by orthogonality? Okay, take a look at this. When I'm, I constructed 2 contrasts. If I multiply the contrast weight of each category, if I multiply them and I add all of that, then it should be 0. Take a look at it. Minus 1 times 0 is 0, right? Half times minus 1 is minus half. Half times 1 is half. Half plus minus half plus 0, that will be 0. That is what we call the orthogonal. If you are constructing a contrast weight and the orthogonality does not hold, then that is not correct. I'm going to say that again. If you take a look at this, I'm talking about the orthogonality of contrast, meaning summation of, the product of the contrast have to be 0. If I have 2 contrasts and I multiply their corresponding weight and I add that together across group, it must give me 0. If it doesn't give me 0, then a mistake has been made in the construction or in the setting up of the contrast weight. Okay, now, just like what I said the other time, the essence of the contrast is just to split the total sources of explain variation into, components, which I'm going to explain. Okay, I have already shown you how to set up a contrast when you are dealing with a one-way analysis of variance. And I want to walk you through now. How do we set up a contrast when you are dealing with two-way Anova? Now, I want you to look at this example on two-way Anova. We have 2 factors. The first one is a drug factor, which has 2 levels, A and B. And the second factor is gender, also have 2 levels, A and B, male and female. Now, this is a two-way Anova because we actually want to look at the effects of 2 categorical predictors on the response. One factor is the levels of drug, the other factor is talking about gender. And how do we set up a contrast in this situation? What is the meaning of contrast? In this situation, we actually, maybe we have a prior information before we actually set up the design. And we believe that, of course, the null hypothesis will be rejected, okay? And we actually want to, compare certain treatment means. Now, I want you to say, if you look at here, I'm considering three contrasts. If you take a look at contrast one, I'm going to give you explanation now. Look at contrast one. You know, the drug is A and B, right? And the gender is male and female, right? If you look at contrast one, you need to for us write the drug A, B, B, because that very drug, may we use it? May we use, the male person is going to use drug A, male person is going to use drug B, female person will use drug A, and female person will use drug B. I think you know that, right? Okay. Now, and then the gender now, male, female, male, female. If I want to construct contrast one, I'm putting half plus half plus half on AA, right? And on male and female, and I'm putting minus half on male and female. What am I testing there? I'm only testing if there's a significant difference between drug A and drug B. That is what contrast one is testing. Is there a significant difference between drug A and drug B? I've used drug A on male and female, and I've used drug B on male and female. Is there any significant difference between that? That is what contrast one is talking about. For contrast two, we put a plus on A. Look at that, plus half on A, plus half on B. Look at that. And plus half on A is a drug A for male. Plus half, okay, for B is a drug, it's a drug B for male. Take a look at this now. Okay, I use drug A for male, and I use drug B for male. Okay, for male. Then I use, I reproduce that for female. What am I testing? Because I put a plus half and plus half on male, and I put a minus half and minus half on female, then I'm only testing whether there's a significant difference between gender, levels of gender. That's what I'm testing. In terms of maybe the drug, is there any significant difference when I use, the two drug A, B on male, and I use it on female? Is there any difference between them? That is what contrast two is talking about. Now look at contrast three. Plus half and plus half is on AB, okay, and that very AB, for male and female, okay, and minus half and minus half on both male and female. Then what I'm actually testing is the effect of interaction between drugs A, B. Now, each of these contrasts is actually sending different information that can be tested. current, a lot of research are going on concerning the way the vaccination works, or, on male, on female, on adult, on kids, and so on like that. Okay. And I think I provided the explanation here. Contrast 1 is talking about the main effect for drug. Contrast 2 is talking about the main effect for gender. And contrast 3 is talking about, like I said, the effect of interaction. And let me tell you this, how do you assign weight? You assign weight in such a way that the sum of the constant will be equal to 0. And not only that, the contrast 1, contrast 2, contrast 3, they have to be orthogonal. Multiplying column wise, if you multiply column wise and you actually add them together, they must be equal to 0. That is how you know whether you are actually constructing very well. Okay, that is that. But do you know the good news? The good news is that with a software hard, okay, this can actually be easily done. And I'm going to walk you through, even though my TA is still going to walk you through this in the lab, but I'm going to show you the code right now. Now, let us take a look at this question. For example, let's say we wanted to compare control A, or I mean control to A. We want to compare control to A, B, and C. And that is in contrast 1. Now, when you take a look at this statement now, from a given statement, you will be able to extract the contrast information. Now, take a look at this. It said, for example, let's say we wanted to compare control to A, B, and C. We are comparing control to A, B, and C. It said, call that contrast 1. And then A to B, contrast 2. And then A to C, contrast 3. In this question, you have been given the 3 contrasts in a statement form. Okay, note that these are not orthogonal. Specify the weight for your contrast and be sure to check the order of the levels of the factors so your weight will line up properly. Create a temporary matrix with each contrast as 1 row. The top row for the constant should be 1 over j for the j row. Get the inverse of the temporary matrix. Okay, then the first column of the inverse will be. Now, I'm going to walk you through that now. You're going to see, even though we want to use a software, the software don't talk. The software don't know what to do until human being instructs. Then I'm going to show you now what you want to instruct the software based on this information. Now, in the question, we're told how many contrasts, right? 3 contrasts, right? Contrast number 1. When you look at the question, how many levels of the treatment you have? 4. A, B, C, and control. And we are told in the statement that we actually want to compare control with the other levels of treatment. And the other levels of treatment is 3. Then each of them, we have a weight of 1 over 3, 1 over 3, 1 over 3. And what they want to compare with, we have a weight of -1. Take a look at that. That was why I got what I'm going to put into our software. I'm going to write C1 less than minus C. I'm going to write -1, 1 over 3, 1 over 3, 1 over 3. Is there anyone who need clarification on how I got -1, 1 over 3, 1 over 3, 1 over 3? Is there anyone who need clarification? You guys are good, right? Okay, because we are comparing control with other levels of treatment. And there are 3 levels of treatment apart from the control. We're going to give them equal weight. 1 over 3, 1 over 3, 1 over 3, and the other one will be minus 1. When you look at the second contrast, we are told that they only want to compare A to B, A with B. If I want to compare A with B, then A is going to be 1, and B will be minus, then other levels should be 0, 0. That is why you have the contrast, second contrast to be 0, 1, minus 1, 0, means you are only comparing 2 levels. And the last one, we are told that you want to compare A and C, level A and C. Oh, level A and C is what I want to compare. Then one we have a contrast weight of 1, the other one we have a contrast weight of minus 1, and every other level will be 0, 0. And that is why you have this. Now this is the information you're going to supply R. Okay. Now, when you supply R with this information, you have to create a matrix. It's going to be a matrix of contrast. I'm just going to write that. If I want to create a matrix, you know what I'm going to do? I have 3 contrasts, which is C1, C2, and C3. But I'm going to put a constant 1 over 4. Why am I putting constant? It's like when we are dealing with a linear regression that we have an intercept, so you're going to put a constant of 1 over 4, 1 over 4, because how many levels, apart from the contrast, we have a C1, we got a C2, we got a C3, and don't forget the levels of the treatment is 4 with the control. Then I'm going to put 1 over 4. Now I'm going to show you the moment you process this, how do we give you this? How do we give you this matrix? Okay, how do we automatically give you this matrix? Take a look at that. Okay, when you see the first one, the first row is that 1 over 4 that I talk about, and this is the remaining. Now, after that, we need to get the inverse. You don't need to worry at all. You don't need any algebraic. Just in R, if I want to get the inverse, I'm going to say solve. Look at that. Solve into the matrix. Automatically, my inverse will be computed. Look at that. Set up the contrast. Get the matrix. Get the inverse. This is the inverse right now. Okay. And after getting the inverse, what are we going to do? Okay, now take a look at this. We drop the first column. Okay, what is the first column that we're dropping? If you go back, the first column is actually 1, 1, 1, 1, 1. Okay, we drop that. We have a code to drop that. Okay, we're going to say math less than math, comma, minus 1. It means I'm dropping the first column. And after dropping the first column, the next thing I'm actually going to do will be something on linear regression. Why am I doing linear regression? Because at the beginning, I told you the linear combination of constants and the mean and the group means is what we call the contrast. That is exactly what we want to test. So right now, you're not going to write model, linear model Y, okay, which is going to be your response on COND. Okay, the COND, let me just show you this. Where we started, okay, we have our data set, okay, $COND, which is going to be the predictor. Okay, now when you take a look at this now, you're actually you are regressing response on the predictor. Okay, just like what you normally do in simple linear regression, you're going to say data equal to data command, then you're going to say contrast equal to least, cond equal to math. What is your math? Your math is that inverse, this one, the inverse. After dropping the first column, it has taken that into consideration. When I do the summary, okay, I'm going to show you what we're going to get. Oh my God, this is what we got. What is the difference between this when I run analysis, one-way analysis of variance? In one-way analysis of variance, I'm only going to have sum of square treatments. Okay, but here, the sum of square treatment has been partitioned, has been splitted into three contrasts. So that you're going to have some of, what the first contrast explain, what the second contrast explain, and what the third contrast explain. And you know what? You will be able to carry out a significant test by looking at the p-value, okay, on each contrast. Don't forget what you are testing in contrast one. What are you testing in contrast one? What you are testing in contrast one is whether there's a difference between control and the other three levels of drug. Now take a look at it. For contrast one, what is the p-value? The p-value is less than 0.05. Then what is your conclusion? There is a significant difference between the control and the three levels of drug. Then contrast two, I think you are testing if there's a significant difference between drug A and drug B. And of course, with this p-value, there is. Now, this result here will enable you to take a decision regarding each contrast. Okay, and that is exactly what we have done here. Okay, so that is what we have done here. And I gave another example. But this time, we have three contrasts. We're talking about a data set on those. We have three contrasts. Okay, if you look at the first one, the levels we're comparing, the levels of those is none, low, medium, high. If you look at the first contrast, we are comparing none and low combined with medium and high. That is why you see the first contrast here. None and low combined with medium and high. That is the first contrast. The second contrast is talking about, is there any difference between none and low? And the third one is trying to say, is there any difference between medium and high? Between medium and high. We do the same thing again. We did what we did before. Finding the set of the matrix, finding the inverse, drop one, then run the model. Response on those, indicate that equal to that, then the contrast, then you're going to get your results. Now, in this table now, it's where you're going to look at the p-value to take a decision on each of the contrasts. Now, if you look at number one, the p-value is greater than 0.05 of this one. And what is the contrast? What is it testing? It's testing, is there a significant difference between none and low in one category, okay, and medium and high in another category? And the p-value, I'm going to show you now the p-value of that one. It's 0.14215. It's greater than 0.05. What does that mean? There is no significant difference between none and low and medium and high. That's what it's saying. The second one, it is significant. What are we testing in the second one? The second one is testing between none and low. Is there any significant difference between them? And if you look at the third one, it's testing, is there significant difference between medium and high? Let me tell you this. Some of you that you have not seen data set for your project, there is opportunity out there for you to get data set with the the COVID data. Right now they just approved vaccination for 5 to 11 years of age. And you know what? If you take a look at no dose, low medium, high. You know, the manufacturers of vaccines, they are looking at the optimal dose that will be given to children, because the kind of dose the adults get, children may not be able to get that. And that is why the use of contrast is very, very important. I may want to consider, you know, I remember initially before the booster dose, why Pfizer actually recommend 2 doses for you to have 95% efficacy rate. I think a vaccine company like Johnson & Johnson is only 1 dose, if I can remember. You get what I mean? So with Johnson & Johnson, they believe 1 dose is enough. This one believe 2 doses is enough. How have we ever asked ourselves, how do they arrive at the optimum dose? They arrive at optimal dose because they have statisticians, they have data scientists, they have biostatisticians, medical statisticians that are really working for them using testing contrast, what we're doing now, to arrive at that. Finally, before I go, the appearance of reality, the appearance of the physical world is independent of human knowledge. I'm going to say that again. The appearance of reality is independent of human knowledge. It means we as human beings, if we want to take decisions that we are not going to regret in this environment, whether medical environment, psychological environment, economic environment, social environment, whatever environment, then we need information. Okay, but I just want to tell you, there are different kinds of information around. Misinformation, disinformations. But how can I rely on the information I'm getting? That is why you are here. You need a proof. Something that is not statistically significant. I don't think I'm going to believe that. We have a way to test. It has not changed. And that is the reason why you shouldn't believe in indoctrination, but believe in evidence supported by scientific findings. And that is why we're doing this. Okay. Lastly, I want to say I've uploaded midterm 2 practice question. This time around, I think I provided a solution. You can walk through that. Next week, I'm going to walk you through that, just like what I did in the midterm 1. And this time around, if you want to write exam, or I think I need you to send a message to me on whether you want to write midterm 2 in person or online. I need that information. And I'm going to send a message across to everyone today, okay, about the latest dates I can receive that information about whether, except when there's a case of emergency, that you can delay your response to the day, let me say some hours to the day or to the exam, because we live in a stochastic world, anything can happen. So please, if you have made up your mind on whether you want to write online or in person, please send a message to me. Okay, make sure you stay safe and have a lovely weekend. This of you online, you have any question?
No, thank you.
Okay, you're welcome. You're welcome. Yeah.